got to. Pull up with a stick, stop it. Rich nigga shit, solid. Rich nigga, oh, 100 pockets rounded.
So, hello everyone. Today, me and my team will present about critical point method and how do we apply it to real life by taking a study case. So, what is the definition of CPM? Critical point method is a technique that analyzes the network of activities in order to predict the total duration. So, the study case that we will be taking is Pecatu 5 Elementary School Construction Project. So the function of critical point method in deterministic optimization is to solve optimization problems, especially in nonlinear programming. The critical point method is used to identify the sequence of important tasks required to complete a project in the shortest possible time. So why do we use CPM in this case? Because in this case, it is important for scheduling workers optimally, allocating resources optimally, identifying critical and non-critical tasks. So these three factors are important so that the project runs smoothly. So here we have the CPM dependency relationship. Here, as we can see, the total duration from working preparation to the electrical works will take around 97 weeks, and there are 19 activities in total. But here, my friend will try to solve it optimally by using the critical point method so that we can find the critical task and the non-critical ones.
So, as we can see from this table, from the data that has been collected, we can create a CPM diagram as in the picture that's shown next to it. Number 1 represent activation code A with a duration of 1 week, which will continue to be, or number 2. But B and C are events that only occur after event A, so we can make it a branch after number 2, as you can see on the diagram. The dotted line after D is called a dummy. Why we add a dummy? Because D can just stop there, and our final goal is electricity. Number 5, continuing after the BDE is carried out. F, G, H occurs after the BDE as well as the next I, J, K, L, M, N, O, P, Q, R according to the available flow data until we get to the S or electrical activation code, which goes to our final destination. And then next will be explained how to calculate it with really.
To determine the critical point, we must find the earliest time and the latest time. To find ET, we must find the maximum value, while for LT, we look for the minimum value. Number 1 is 0 because it is the beginning. Number 2 is 1 because its duration is 1. Number 3 is 3 because it is 2 plus 1. Number 4 is 5. And for number 5, since this section is branching, we will determine the maximum point by comparing the result and entering the largest value. We will calculate B and C, 1 plus 6 equals 7, and 3 plus 3 equals 6, and we get the value 7, and so on. For number 16, because this section is branched, we will calculate PQS. The results are 10 plus 13 equals 23, 16 plus 6 equals 22, 20 plus 5 equals 25, so the value is 25. To find the latest time, we will count from the back. Number 16, which is 25, because it is the final time. Number 12, we get 25 minus 5 equals 20. Number 6, we get 20 minus 11 equals 9. Number 11, we get 25 minus 6 equals 19. Number 15, we get 20 because of dummy. Number 12. Number 9, because of branching, 20 minus 6 equals 14. 18 minus 3 equals 16, then we get 14. Number 7, because dummy, then 25 minus 13 equals 12. 14 minus 3 equals 11, then we get 11. Number 7, dummy, then 25 minus 13 equals 12. 14 minus 3 equals 11, then we get 11. Number 14, because dummy, then 25. Number 7, dummy, 25. Number 10, we get 25 minus 10 equals 15. Number 8, we get 15 minus 3 equals 12. And to find number 5, we have to compare FGH and take the smallest one. 8 minus 2 equals 7. 11 minus 3 equals 8. 12 minus 5 equals 7, then we get 7. Number 4, because it is dummy, then 7. Number 3, we get 7 minus 2 equals 5. 7 minus 3 equals 4, then it is 4. To find number 2, we have to compare B and C. 7 minus 6 equals 1. 5 minus 2 equals 3, then we get 1. So it can be concluded that critical times are number 1, 2, 5, 6, 8, 10, 12, and 16. Because ET and LT are the same, which means that delay can affect the project.
So, the conclusion of this case is that on the critical path method or CPM with a total duration of 25 weeks or 175 days, the critic path method has a mathematical calculator that is easy to understand but has only one logical relationship. CPM can provide valuable insight into how plan a project, allocate resource, and schedule tasks. As for the advanced of the CPM method are as follows. The first can help planning activities, especially on large value projects, and the second CPM has simple calculation. So it will not complicate the planners and directly on the planner concept.